Okay, testing 1, 2, just making sure that we're recording. Good. So we're getting pretty close to wrapping up most of the content that we really need to cover in the class to do your assignments. So last week we kind of finished up covering the basics of materials and importing 3D models, stuff like that. And the last part of the technical art unit is particle effects. So we've covered how to create kind of like solid objects like this. We've covered how to add surfaces to those objects. But now we should think about how to create things like dust, smoke, lightning, things that aren't solid surfaces, but nonetheless add a bit of character, a bit of life to a scene. Okay? And Unreal Engine has a module inside of it called Niagara, which is used to be a plugin, but then it got bought, and now it's their default go-to particle effect system. So in my project folder, I've just created this folder for effects. And that's going to be where we put all of our particle effects assets. Okay. And I've gotten started just because I needed to review a little bit in order to prep for this, but so I've just created this folder for emitters. And that's because Niagara has two components. Well, FX systems in general have two components. And if you right click under the basic assets, you can see the first component, which is a Niagara system. Right, Niagara system. And if you hover over it, it tells you what it does. It contains multiple Niagara emitters to create various effects. So let's kind of close our eyes and imagine something like fire, right? If we wanted to create a believable looking fire effect, well, we'd have the flame itself, we'd have smoke, I'd have embers, little bits of debris that come off of the burning wood, stuff like that. Each of those separate pieces would be an emitter, and then we'd bring them all together in a system, right? So if you come down here to FX, you can see you can create both individual emitters and then Niagara systems. Just for ease of use, we're going to start with a Niagara system. And we can just click Niagara system. Okay. And here you have a couple of options. Now, in our case, we don't have any existing systems. We can look at some templates, which are a good place to start, or you can just create like a blank template here. But we're going to start from a template just so we can see some of the existing behaviors and kind of how they work. Oh, no, sorry, we're going to show new system from selected emitter. And you can see here a whole bunch of just kind of examples that are provided by the engine, like blowing particles, which is like leaves blowing in the wind. We have a confetti burst, which is like I don't know if you've ever used where you pull the string and confetti flies out of it. Directional bursts, beams, fountains, what have you. Let's just pick this first one for the blowing particles because it's a good example of how Niagara systems work. So you can see each of these are individual emitters, and we're just clicking plus to add them to the system. So I'm just going to start just by adding this blowing particles and clicking finish. And I'm going to call this, I guess, FXS for FX system, blowing particles, because that's kind of what it is. And I'll go over how to create this again in just a second. Now it's going to take a second to load, and you'll see it's sort of similar to our material editor here, where we have our previs window here. And let's see if we can see any of our particles. Don't really seem to be able to. So I'm just going to click compile to see if that's the issue there. I'm waiting for shaders to compile. Because ideally what this should be is a whole bunch of kind of little particles, little flecks floating through the sky. Okay, and it's just going to take a second to compile. And you can see now we have all of like these little particles that are kind of rotating and flying through the air like that, right? Can make this is a lot easier to do when you have two monitors because you can take the preview, put it on one monitor. This is kind of what we end up with. Okay, so just to review how we did this, I right-clicked, went to create a Niagara system, and it's saying new system from selected emitters, which allows us to pick a whole bunch of different effects that we want to layer in order to create a particle effect. And I just selected blowing particles from the list, added it, and clicked finish. Okay. And that gets us something like this. And in here we have two output nodes. This blue one here is for kind of like high-level settings that control the entire system. And then you can see this one here, which controls the behavior of one single emitter. And the example I used was if we wanted to create something like a fire effect, right? We would have multiple emitters. We'd have an emitter for the fire, an emitter for the smoke, an emitter for the embers, emitters for every kind of little thing that makes an effect believable. And in this, you can see if I can zoom in a little more. Here we go. You can see we have these kind of drop downs. I'll just minimize all of these to make it a little easier. So we have the emitter update, which is kind of like tick. If you can imagine this is called every frame. And inside of our emitter update, we have controls for how often we want the particles to spawn. So right now it's set to a spawn rate of 15, right? We have our details panel. I've just selected this little spawn rate behavior. That's all it is. It's just a behavior that we kind of drag and drop to give this thing properties. Let's say I want to increase the spawn rate. So I want more particles to be flying through the air. I can change this from 15 to 50. Now you can see we're getting more. I could change it to 100. And now we're getting even more. You can change it to 1,000. And now you can see it's like a blizzard, right? And here we have this thing called the emitter state, which allows you to control basically how long you want it to last. So loop behavior, for example, is set to infinite, which means that it will just keep looping infinitely. But if I set it to only loop once, it'll only play through the duration of this particle once, and then it'll stop playing. And in terms of when you want to use once versus infinite versus fixed, I don't know. It depends. It depends on what kind of effect you're trying to make. Okay. Within each of these dropdowns, so emitter update, particle spawn, particle update, and render, we have this little plus button here, which lets us add modules to the group. So in this case, spawn rate is just kind of controlling how many we're spawning and the rate at which they're spawning, right? So in this case, I believe it would be 1,000 per second. Or we could set it to, again, back to 15, which was the default. But if you click on this plus, you can see we have a whole bunch of different modules, basically, that we can add in. For example, if I look for add velocity, maybe usually it filters for the ones that you're allowed to add in each single one. But you can see things here like sample skeletal mesh. If we want to spawn these on like a character, we can spawn them on a character. But that's the idea, is you click plus and you look for a module that might add the kind of behavior that you want to add. If we go to particle spawn, oh my goodness, what's going on here? Okay, if we go to particle spawn, we have this one here for initialize particle. And this allows us to set things like lifetime min and max, which is how long do we want each particle to exist before it gets destroyed. So in this case, each of these little floating dots that rotates around lasts between 12 and 15 seconds. It's a random range. We can set the color, right? So right now these particles are white, but if I want to set these to, say, red, I can do that by opening up my color picker and setting the color to red. Now you can see my particles are now tinted red. A little bit. And you can alter the physics, like kind of the physical properties of the particle here. So things like mass, how heavy are they? How big are they? So right now they're between 4 and 8 centimeters, but if I set this to 10 and 50 centimeters and click compile, you can see now all of my particles just got bigger. Okay, there we go. And if this seems a bit confusing, if this seems like a lot, that's normal. It is. This is kind of the most challenging aspect of technical art, is particle effects, especially getting ones that look really good and believable. Right. So the particle spawn basically controls what the kind of initial state of each particle. So our initialized particle allows us to set the properties for each individual little sprite in our effect. Our shape location here, you can see it says shape location sphere. Basically means what's the area that we're going to spawn these particles in. In our case, it's a sphere with a radius of 3 meters. And initial mesh orientation is basically controlling the orientation of the sprites. Because if you can imagine each of these is just like a flat, like a leaf almost, right? It's just a flat leaf. How do we want them to be oriented when they spawn in? Right now, we're just saying spawn them in a random rotation and position. Okay. Next to each of these, we have these check marks. So we can disable each of these if we want. Like if I disabled this initial mesh orientation, you'll see that they all spawn in like a very uniform way. Wait for this to compile again. Oh my goodness, it's killing me. There we go. Okay. So particle spawn basically controls the initial state of the particle when it spawns. Particle update is where things get interesting. Okay. So particle update, you can see here we have a whole bunch of modules that have been added to our particle update to simulate the wind, to simulate gravity, to simulate aerodynamic drag. So this is basically like, how do we want each particle to behave after it's been spawned. So in our case, we're applying gravity. We have this wind force where we can set the wind speed. Look, if I set the wind speed here, it's set at 200 in the x-axis. If I set this up to 1,000 in the x-axis, you can see now all of my particles are just moving that much faster because the wind has gotten faster. We can set how turbulent the wind is. And that's the basic gist of particles, right? This is obviously just like a template. It's a very simple example. If I minimize these, we have all of these different kind of components of a particle. So what we want the particle to do every frame, what we want the particle to be when it spawns. And then finally, this last one here for render is what we want the particle to look like. And you can see here that these are just like these little round discs, right? And that's because here for our material, we just have this default sprite material, which is just a material that renders a little round disc. That's it. Okay. But we can set this to render other things as well. So right here, we're using a sprite renderer, but I can also, I believe, use a mesh renderer. So I'm going to disable my sprite renderer. And add a mesh renderer. And now instead of just rendering these little round discs, we can actually use 3D models as our sprites as well. And I'll just wait for this to come up. And right now it's just using this s_no_on, which is just like the 3 axes, and it's useful for showing like the orientation and rotation of our particles. But let's change this to our rubber duck that we imported last week. Now we have a whole bunch of rubber ducks blowing in the wind. Right? So again, to kind of summarize, we have our particle spawn, which controls the initial state of each individual part. So each of these rubber ducks is a particle. The particle spawn controls the initial state of those particles. Like if I want to change the size of these, right, I have my initialized particle here. I can change the size from, so right here you can see my sprite size mode under my sprite attributes. Right now it's set to random uniform. I can set this to between 50 and 100. And it will change the size of each one to between 50 centimeters and 1 meter. You can see the sprite rotation mode is set to random. We can just set it to a direct angle in degrees. So each one is going to be rotated by 0 degrees when it spawns. Okay. So that, again, just the main takeaway I want you to have is that we have these kind of different sets of modules that control the particles at different points in time. And we can just add different behaviors as we need them, right? So I'll go into my particle update. Maybe I want this to be more of like a duck tornado instead of a duck wind force here. So right now, all these ducks are just blowing away in the wind. I can click plus here under my particle update. And you can see all of the different, there's tons, right? If I come down here to velocity, I can add maybe this vortex velocity, right? Inject an angular velocity around a angular velocity around a vortex axis directly into the particles. Let's see what this does. And I'll also disable my wind force here, just to see, just so I can kind of isolate this vortex velocity and see what happens. And then I need to hit compile. Compile and save. Okay, there we go. And if all goes well, it'll now be like a duck tornado as they're going around this vortex. You can see the velocity amount isn't very much. So I can increase this velocity amount to say like 1700, maybe even a little bit more. 100,000, there we go. Now we've got ourselves them moving around in this vortex. Could maybe take that down a little bit. It's a little extreme, like 75,000. Now we've got ourselves a little tornado, right? And you might be asking yourself at this point, like, well, how do I know which modules to add where to get the effect that I want? And the simple answer is you just try a whole bunch of stuff until it works. There's like, let's say you want to make a snowstorm. You can say, okay, Mr. Murphy, how do I make a snowstorm? Well, I don't have the answer for that, right? That I used to work as a video editor. As a kind of an industry story. I used to work as a video editor, and we were doing this like house hunting show. And the producer came to me, so this is kind of my boss, effectively, came to me and said, oh, you know, like it was at this seaside town that this show was set in, and he goes, oh, do you think you can add like a ghostly pirate ship? Just like add it into the shot. And I said, yeah, let me just press 11 or press F11, and that's the ghost pirate ship button. No, I can't add that in. You don't have footage of it, right? The point is, I don't know how to make every single possible particle effect. So how do you know what to add? Well, you would look at reference, right? So if I wanted to make a tornado particle effect, I could go on YouTube and I could look at tornadoes. Right? This is what I would do, right? I would say, okay, so it seems to be kind of like a smoke effect that is added to a vortex. You might have, okay, we've got some like debris and stuff that's floating around it. That's a little bit like wider floating around it. So I would say that this particle system would be made of two emitters. We have the one emitter for the kind of, I don't know what you would call this, the kind of steam smoke effect that forms the pillar of the tornado. Then I would have another one for all of the debris and crap that orbits it a little bit wider. So let's see if we can make a tornado, just for fun. Now, instead of creating a particle system to start, so this is what we did before. We said, we right-clicked, said Niagara system. We're not going to pick a Niagara system this time. I want to isolate each component of my emitter and then assemble it all together when each piece is done. So instead, I'm going to come down to the FX here. Instead of choosing Niagara system, I'm just going to choose Niagara emitter. And I'll say new emitter and next. Now, in terms of which template I could pick, because I can like copy from the existing templates that Unreal Engine has provided. I mean, maybe Fountain would work, because if we look at, again, the way a tornado moves, it seems to be like this kind of upwards motion, right? So we could probably pick Fountain. That might be a good place to start because it's like it's spraying upwards. So I'm going to pick Fountain to start. And instead of FXS, which is for our FX systems, I'll say FXE for FX emitter. And I'll call this tornado center. I don't know what you would call that. Tornado center. Then you'll see it takes a minute to compile. If I hit save, this is what we start with. Well, I know from my duck tornado that a good place to start would be to add a vortex, right? Vortex velocity. We also have this one here called vortex force. We could try both. I'll add vortex force and see what happens. And I'll increase the vortex force amplitude here, which is like the strength of the force, maybe 1,000. And I might disable gravity to start because it doesn't seem like there's a great deal of gravitational pull on the start of our twister. Add a little bit more of this vortex force. And that seems like a fairly good start. One issue I have, if I look at my reference here, is that it doesn't seem to form from a single point. It kind of forms from this cylindrical, this round base, right? And if I look at my fountain, it's all spawning at this one very narrow point, right? So we would control this based on where we want our particle to spawn to begin, right? So we could come to the shape location here. It's provided us a shape location of sphere. And the radius of our sphere is currently 8 centimeters. Okay, we probably want it to be a bit bigger than 8 centimeters. Let's try something like 10 meters. Okay, now if we zoom out, we've got this, and that's sort of looking a little bit better. Although I would say the particles probably need to be a little bit bigger in order to kind of fill the whole thing. So we want to change the size of our particle when we spawn it. So we pick our initialized particle. This is kind of an important one. This lets you control a lot of kind of the more basic properties of your particle, the size, the color, rotation, stuff like that. So here I'm going to change the sprite size mode from between 6 and 12 centimeters to like between 100 and 200. Okay. Getting a little better here. I'd say probably want some more force and probably want more particles in general. So we can come to our emitter update, which controls not the individual particles, but the whole emitter as a whole. We got our spawn rate here. Let's set this up to something like, I don't know, 1,000 particles a second. Okay, we're sort of getting closer. We could come to our vortex force here, change this up again, something like 5,000. I'd say the main issue I have here is that now the vortex force is kind of like spreading it out. It's pulling it away from the center. So maybe there's a way to fix this. And if we just look here, we say origin pull amount, and it says an optional pull towards the vortex origin. Hey, perfect. If I set this to 1, let's see what happens. Maybe. Getting closer. Origin pull now only pulls the vortex and I'm playing 3D. This keeps particles in a more stable rotation plane. I don't know, let's try disabling this. Maybe this will make it look better. We're getting closer. One way we might be able to prevent the particles from kind of flying out for too long is we could change their lifespan. Maybe they're just existing too long, so all of this force, as they get thrown out, they just, we just see them for too long. We could come to our initialize particle here, and up at the top we have our lifetime mode. I can just change this down to maybe 0.8 seconds and 1 second here. There we go. So we've got kind of this like orbiting thing of particles, but now we want it to kind of move up. We have this add velocity here. And this is one way that we can do it. So when we spawn our particle, what add velocity does is it says spawn it moving in this direction, right? And in our case, we're spawning it going up, and we're not really giving it a whole lot of speed. So instead, what I'm going to do, I disabled my gravity force here. If I re-enable it, you'll see that my particles will start kind of falling to the ground a little bit. And that's because my gravity is set to negative 980, which is Earth's gravity. Negative 9.8 meters per second is the amount of force applied by Earth's gravity. Let's just set this gravity force to like positive 1,000 and see what happens. And it should start pulling them up. Positive 10,000. Okay, now we're getting somewhere a little bit. Maybe we just need a bit more vortex force to kind of compensate for the gravity. Oh, let's see if this works. Right? Okay, so we have kind of a basic. We could probably spend some more time making this nicer, probably add some more. If I go vortex velocity as well as vortex force, maybe this will help improve it. We'll see. It doesn't really seem to, but again, I don't have the answers on how to create every single possible particle effect. I tend to just go in, test things out, and try and get it to work. And when I kind of more or less have it working, I say, okay, good enough. Now we might want to add our debris into this, right? So I can right click, go to my FX, create another emitter. Say new emitter. Now in this case, a fountain, maybe it'll work. We could probably start with here, start with a fountain to start again. And go FXE, tornado debris. And just to distinguish this from my tornado, when I initialize my particle and set my color, I don't want to start it as a white particle. I'm just going to start it as like a dark gray particle like so. And kind of do the same thing where I take my gravity force. Actually, with the debris, if we look at our debris, we can see it's not really moving up so much as the smoke at the center is moving up, and it's kind of moving very slowly, orbiting around it. So we probably don't need to mess with the gravity force too much. We'd want to increase our sphere radius, probably to something like this, and do the same thing where we're just going to add a very slight vortex velocity. And just kind of take that up a little bit like so. And crank it a little more and see what happens. Okay. So now if we want to bring these two emitters together, we can right-click and create a Niagara system, right? So the individual emitters are like modular pieces, right? Let's say I have one tornado that is just like, you know, kind of the classic kind of twister that might form in the Midwest. But then I want to do another particle effect that's like a fire tornado. Well, I might then create another emitter for a fire tornado, but then I still want debris to orbit around it. Well, I can just use this tornado debris emitter that I've already created as just a piece on other effects, right? So we want to try and break down all of the effects that we create into smaller pieces that we can reuse very easily. So I can go in here, create a Niagara system. I'll go new system from selected emitters. And now I believe we should be able to see somewhere in here, if I click show all, should be able to see here we go. If we go to parent emitters, we should be able to see the emitters that we created. So I'm going to add my tornado center emitter and my tornado debris emitter and click finish. And we can call this FXS tornado. Now if we go into our tornado, you can see we have the emitter that we created for our tornado center and then the emitter that we created for our tornado debris. Okay. We could spend a lot more time polishing this. Like I would say, probably assigning a different material to this sprite render to make it look more like smoke would be a start. Replacing this tornado debris, the sprite renderer, with a mesh renderer with some debris 3D models. I'm sure we could figure out how to do that. But once we're happy with our emitter and we want to add it to our level. So here's the level, you know, very simple, done a whole bunch of demos in it. I can just click and drag this system into the world. And now you can see my tornado is in the world. Okay. And it's kind of nice to do it here because I can immediately look at this and say, well, this tornado is not tall enough. These particles need to last a little bit longer. They need to be a little bit bigger. And this is where I can then go back to my individual emitters, like my tornado center, and modify them. So I would say my lifetime is not quite long enough. So I'm going to set this to between 10 and 20 seconds. We'll see how that works. I'm going to disable this add velocity in cone because I think that's what's kind of pushing it out towards the top. I'm just guessing. I don't know. I just think when I think add velocity in cone, that's probably what's doing it. I'm going to increase the pull amount here to the vortex origin. So hopefully it just pulls things in just a little bit. We'll see. And vortex origin. Fall off factor based on distance from the vortex center. Use influence fall off. Okay, this could be a solution. Here we go. So I found this setting on my vortex source that controls fall off. Now, fall off is a way to say, okay, as it gets further away, apply less of this effect. And maybe this will be the solution here. And again, I'm just kind of playing with these settings until I get something like, I don't know what all of these settings do going in. I don't think anybody on Earth has memorized every single module that Niagara has, every single setting, and what all of those settings will do when they interact with every other module. There's just way too many combinations. Okay. So for your assignment, for your final assignment, it's just create a system. Create one system, any system you want. You can use it in your level or not. Pick something that you like, something that you find interesting, look at some reference, and start with something like this, just using very simple sprites to kind of block out, kind of like we did with our level, right? We just use very simple shapes to kind of get the look and feel of our particle. And once you're here, then you can say, okay, I want to change this from like a flat, simple circle of a sprite into something that looks more like smoke as it pulls upwards, right? Because at that point, you don't need to worry about the way that it's moving. You don't need to worry about the way it looks and the way it feels. It'll look and feel like a tornado, and you can just make small improvements as you go, right? I'm gonna add the velocity and cone back because I thought that looked a little better. I'll change this vortex pull amount down a little bit and just kind of try different things. Okay. Any questions about how to create an emitter, how to create a system? I realize that this is a lot, and this is probably very unfamiliar to most of you. Okay, that's fine. The assignment is just to, again, let's say you want to create a fire. You go on YouTube, you say, like, I don't know, like campfire reference video, right? And you can look at just like reference footage of a campfire. So this one, you can see we have the smoke coming off the edges there, and then we have the fire itself. You can just go and look up tutorials as well. If I look up Unreal Niagara tutorials, you can see that there's all kinds of options here for figuring out how to create different effects here. I don't care if you pick a tutorial and say, well, this is the one that I followed because this is the look that I want. That's fine too, right? Just include the tutorial you followed as a like a citation, right? Okay, so now that I've made these changes, I can compile and apply them. And I can then see the changes that I'm making here. I would say probably my upwards pull is a little too much. So if I go to my gravity force, I can change this to like, I don't know, 5,000 in the up direction. Okay. Or why when I turn the vortex velocity on, it just kind of doesn't do anything. Okay, that's the basics of Niagara particle effects. I don't really have a whole lot to go over. I'll be honest, particle effects are not my field of expertise. I mostly do materials and shaders, but I can kind of get by. Another good source of reference if you want to learn about how to create more particle effects, I believe if you go to this quickly add content to your project here and you go to the Unreal Marketplace, it'll take you to this, which is like a link to Fab, which is basically their asset store. And they do have some free sample projects where you can see just how they've created particle effects, right? If we go to the assets from Unreal Engine, you can say like Niagara sample project, I believe they have one. And we'll filter by free just because I shouldn't have to pay for anything. And usually they'll have just some like free examples from Niagara that you can look at, like fire examples, just visual effects. Obviously, don't just take one of these and submit it as your own. Don't do that. But if you look at something and you think it's really cool, you can look at it and say, well, how is it they did this? Because anytime you import one of these into your project, you're going to see basically all of these assets in your project, and you can just double click on them, open them, and just see what they've done, see how they've done things. Okay. That's really all I wanted to go over today. We don't really have a whole lot of extra content to go over for the remainder of the semester. So I'll continue to go over materials and particles in future classes, but it's mostly just going to be, you guys working on your stuff and me being available to help you with it. Don't leave this to the last minute. It's a lot harder than it seems, especially if you've never done it before. So if you can, come in for the next 4 classes and just hammer out your last 2 assignments, I would recommend doing that. Okay? Yes.
Can you have a look?
Sure. Yeah.
I'm not sure I understand. Okay, I think I know what's going. If you open up the cart, so. Yeah, so. And scroll down a little bit to find the setting for generates collision or generates overlap events. It'll be under the collision tab. Generate overlap event. Just set that to false. We'll see if it happens. Compile and save. Yeah. Yeah. Oh, let's put cancel for a second. Nice. Are you on version 5.5? Why? Never seen that before. Doesn't. The time being, you can just select one. So regards NATO center to start. Okay. In our NATO system, open this up. Just try and do it like this. You can just click and drag. More into it like that. Yeah.
Big bugs. So tiny, practice. Oh. I'm sorry.
Good question. So we have this. What you can do is you can, if there's, I have to remember how to kind of get spline. So our spline is an object, and that object has a whole bunch of functions on it. And one is called get closest position on spline. And it takes an input of a position. And it's going to find the closest point on And then we can say compare the distance of these 2 points, right? So if they're, yeah, exactly, if it's over a certain distance, you would start a timer. There's a function called set timer by events. And what it would do is every frame, it would just check to say, well, are you back in purpose? Is it less than this? And if it is, then we'll just set the timer. And if it isn't, keep going. And then once the timer is up, we would grab the player, probably disable their inputs, put them back on the track, and then re-enable their inputs. So let's see if we can do that. The first problem that we would have is just getting the landscape spline. I'm going to exit this here real quick. So for this one, right, so if we go to landscape mode here, you can see we have our landscape spline. We need to get a reference to this. Now, I'm actually not sure how to do this because I've never done it before. So I'm just going to do a quick Google and say, like, Unreal, how to get landscape spline. So, landscape spline in Blueprint. And use the get landscape spline node in your Blueprint to retrieve the spline data you want to manipulate. Okay, maybe let's try this. So I'm going to open up my cart because I think it makes the most sense to do it here because it's really, we're tracking the distance from the cart to the spline. So we'll just try extending our cart here. So I'm just going to right click and say get landscape. Okay, get landscape subsystem spline. AI, you're lying to me. Cast to landscape spline actor. Maybe we can say get all actors of class. Landscape spline actor. So what I'm going to do is I'm just going to say get all actors of class and select my landscape spline actor. So landscape spline actor. Right, and let's just loop through this and print everything that we get and see how many splines we have in our level. So we have this array of outputs, and I'm going to say for each. And for my loop body, I'll just print string and just print the name of it to make sure that this is actually getting our landscape spline. Okay, so it doesn't seem to be getting anything. Unless I'm using the wrong cart. This is the right one. Go to access landscape splines in Unreal for pathing. Spline actor, use spline component. I'm just looking to see if this guy spline clear spline points u landscape splines component landscape splines equal landscape dot spline component. So yeah, that's how I would do it. Is it just somehow we need to get the spline. So that's the first problem. It's just like getting a reference to the spline. So I just got to figure out how to do that because I'm not entirely sure.
Pathfinder lines, fine. That's pathfinding. Can I access from a blueprint? Taking a shot in the dark. We got splines for. Seems like the other people are having this issue as well. Let's check the documentation and see if it's editing a spline, applying splines to the landscape, spline properties. Landscape spline to spline component. Here we go. Copying a landscape spline to a spline component. In a spline component, the information about a spline is stored in an ordered array of control points. Spline component cannot fork. Splines can fork, so the data about connectivity is stored in. Spline segments. To get a spline component, I split the spline. Oh my God. Tundra, Jesus. This is pretty involved. This is more involved than I thought it would be. I counted differently, world partition. Well, let's see. Call me curious. I'm just going to add a variable and call this track. I'm going to set it to a landscape spline actor, landscape splines component. And I'm going to make this visible to see if we can just like set it. So if I select this here, we have our track. No, okay, that's not working. Landscape splines component, landscape spline actor, object reference. Landscape is not compatible, eh? Huh. Access. Landscape spline in blueprint. Okay, so this might be a bit more complicated than I wanted it to be. Is it possible to select all landscape splines? Accomplished by creating a custom actor class in C++ that lets you copy it into an easily accessible spline component. Okay, so one way we could do this, the quick and easy way, is I can create a blueprint class as an actor and just call this like BP underscore track. And then add a spline to it. And you can see that this is just like the spline that we have in our landscape. We can move it around, hold Alt, and click to add more points. And in our case, it's going to be a closed loop. And then what we do is we just drag and drop this in and kind of draw a copy of our track, like a very simple copy of our track. Because for some reason, we just cannot get the, what do you call it? So if I go, I'm going to go to lit perspective, whoops, to top. Where's my landscape spline here? Track, there's my track. What I can do is I can just kind of do a very quick thing like this, where I create basically a separate spline that follows along with the track. And then we're just going to get this one from our blueprints because it's easy to get a spline component, but clearly very difficult to get a landscape spline. And you can just hold Alt and click on your points to copy them. And you just kind of oops, come on now. Kind of move it so it's as close to your track as you can get it. I wish I had a better answer for you, but this is kind of the quick, easy way of doing it. Right, so I would do this. And let's just say like that's, I'd probably add another point here just in case, like so. Okay. And then in our cart, we'd have a variable for BP underscore track. So this would be a reference to our track. And then we just do the same thing. We'd say get all actors of class, BP underscore track. And in this case, we just want to get a copy and set our track variable. Okay. And then what I'm going to do is on tick, just to kind of test to see how this is working. So on event tick, we have, this is controlling how we steer, adding force and torque and stuff. So I'm just gonna expand this a little bit. So we have our track. We can say get spline, get a location. Get spline location, get location at closest point on spline. I'm pretty sure there was find, okay, here we go. Find location closest to world location. And we're just going to say world location. So what this does is we're basically giving it a position, and it's going to find the closest position on our spline. And for the world location, we just want to say get actor location. So this will return the location of our car. Now I believe we have a function if we just say distance vector here, it gets the distance between 2 points. So then we compare the distance between our car and the closest point on the spline. And for now, I'm just going to print string and see what we're returning, because I don't know what we'd return at this point. Right now, it seems like we're 2.5 meters away, give or take. Good. From the closest point on our spline. Oh, okay, I see what's going on. It's also printing a bit much. Get actor location, get closest spline, world location. I'm just going to set the key to distance to track, so we don't spam our log with a bunch of nonsense. Yeah, so it looks like it's saying we're 2.5 meters away. So I'm going to go to my player start and make sure that our spline is like really close to make sure that we're getting an accurate measurement. Because if I go to my perspective mode here, it could be that my spline is just like sitting super far underneath my track. Yeah, or sitting really far above my track, right? So then I'd want to go in and just kind of position it like so. So if I move this spline so it's closer to the ground like this, and then I hit play, you can see, yeah, it's saying that we're much closer to it now. It's saying 700. I'm wondering if find location, given a location in world space, return the point on the curve that is closest to it. Closest. Find tangent from closest point on returns the distance and closest point to the collision surface. No. Find direction closest to world location. Find location closest to world location. Yeah, this would be my guess, and then once you have this in place, you'd probably want some option, because what it's doing, I think, is just returning the closest, like finding the closest point and saying what's the distance. So you'd want to have like a lot of points that kind of break up like so. And then say, well, if you get too far away from any of these points, then, oops, what happened there? Then restart. So if I click compile and if I hit play, I'm just going to drive through and see what it's returning, because right now it should be super close and remain super close. 200, there we go. And if I get further away, yeah, it's just returning the closest point, not the actual closest location. Although 300, yeah, it's staying reasonably. So then we'd say like, okay, if you get like 20 meters away, like if it's over 2000, find the closest point on the spline, move them to that location. It would be tricky to then get the orientation, like you'd need to somehow find the direction that they should be facing as well, which is in the direction of the curve. So this is where we get more into like, do you ever take calculus or algebra or anything like that? Yeah, okay, so you would get the tangent, right? So if we have a curve like so, say that's our curve, and our player gets to be out here, we'd say, okay, well, find the closest point on the curve, which we're already doing, and set the player position to this, set this to be their location. However, let's say the player was facing this way, like they're facing away from the track, because this is kind of what's happened. They've chosen to drive away. They would still, if we just set their position, they would still be facing that direction. So we can get the tangent of the curve as well. So the tangent is like the direction that the curve is facing, right? So if we have, let's say this point here, the tangent of the curve would be like this. And the tangent of the curve here would be like this, and the tangent here would be like this, right? And we have a function for that that just says like get tangent at position. Same way we can get the location, we can also get the tangent. And then what we do is we get something called a look at rotation, which is basically saying, okay, if we have an object, right, that has no rotation whatsoever, what's the rotation that would get it to look in this direction? And so you take the tangent, you'd say, okay, get look at rotation from this tangent, and then set the player's rotation to the tangent, basically. Does that sort of make sense? Okay. So yeah, let's see if we can do this. Okay, so event tick, we have our thing here, and we'll just say if the distance is greater than 1000, then we use a branch node for our if statement. If it's greater than 1000, we can then say set world location, or set actor world location. Set world location. Come on now, where is it? Set world location. Okay, set world location for our box, which is kind of our root component. Kind of weird, we can't just set the actor location. Okay, here we go, set actor location is what we want. And we're just going to set it to the closest location here, because that's the closest location on our curve. And we'll see if this works. Fingers crossed. So I'm just gonna, yeah, I'm gonna just drive off into the middle of nowhere. Okay. Yeah, okay, so I'm getting too far away and it's sending me back, right? This is where we'd want to be really disciplined and make sure that all of our points kind of snap to the ground. If I select a point, I wonder if this works too. If I select this and set end, okay. Do you have the end key on your keyboard? End. No? Okay. Yeah, it's like you have insert, home, page up, page down, delete, any of those? Because if you hit the end key, it'll just like snap things to the ground. So I just snapped it to the ground there. So if I just go through and do this with all of my points, hopefully, fingers crossed, it'll snap me to the ground. So if I drive too far away, oh, okay, it snapped me through the floor. Okay. But this is kind of what winds up happening. And I think I can see why this is happening. And it's because my cube is kind of halfway through the ground. So what I might do is instead of just setting the location like this, what I can do is just add, I don't know, like 200. I could probably like get the box extents. Actually, I'll do that. Get box extent. And then just add the Z extents of the box. So we're setting it to that location and then moving it up based on how big the box is. That just hopefully will make sure that we always spawn above the ground as opposed to going halfway into the ground. I don't know. We'll see. So if I just, again, just drive away, let's see what happens. Okay, yeah, there we go. Okay. That's not bad. That's kind of doing what we want. Okay. But now we want to set the rotation as well. So for this, we can just say get rotation, find rotation closest to world location. Okay, do this. And then we want to set actor rotation, maybe? Okay, and then we want to set this to worlds. And we'll just do the same thing. And I would go back and clean this up later to make sure that it actually is like clean and sensible. So if I now drive off in the middle of nowhere. Okay, so it's spawning me facing the wrong direction. So I'd want some way to like invert this maybe. Invert rotator. That might make me spawn upside down. We'll see. It's my guess. My guess is we're going to spawn upside down, but we'll see. Okay, there we go. Sort of working. Not great, but sort of. And yeah, I put this together in what, half an hour? So if I spent a day on it, I could probably make it a little better. I hope this makes, yeah, Yeah, you want to play with the values and make sure that it works and all of that. Yeah, there's lots of approaches.